Next, we're going to talk about scale factors and scale drawings. So this is on page 38 in your math book. So we are given this circle, circle A. It has a radius of 4 units. We are going to draw a new circle, circle B, which has a radius that is 50% the length of circle A's radius. Well, we're thinking 50%, that's another word for half the length of the radius. Well, our current radius is 4 units, which we can verify right here. So what's half of 4? 2. So I'm going to come over here where I have some space. I'm going to put a center of the circle, that is B. And now I'm going to count a radius of 2. And so I'm going to make 4 points. I'm going to go up, down, left, and right. So 1, 2, count over 2, 2, and 2. And then from there, we just do our best to connect to make a circle. If it's not absolutely perfect, it's okay. Okay, so now we have our circle with our radius length of 2. Well, 1/2 is the same as 50%, which we said. Well, what decimal is that? Remember to go from a percent to a decimal, we move it over 2 to the left, so we can get it as 0.5. Or as the fraction, we can do 1 divided by 2, and that will also give us 0.5. Well, now let's take a look at number 2. It says, write each ratio to compare circle B to circle A in fractional form and as a percent. And we're going to determine the ratio of the circle's radii. Well, with ratio, order matters. It told us circle B to circle A. So what was the radius of circle B? Well, right up here it was 2. And then over the radius of circle A, which is 4. Well, what does that simplify to? 1/2. Well, 1/2, like we talked about earlier, is the same as 0.5 or 50%. Interesting that we got that again, just by the ratio. So now let's flip over to page number 39. And you're going to see this worked example at the top. So that scale is a ratio that compares the two measures. So that's what we just found with the 50%, the 0.5, and the 1/2. Now a vocab word that needs to go in your vocab section is scale factor. So when you multiply a measure by the scale, so that ratio, to produce a reduced or enlarged measure, that is our scale factor. So that means when we multiply by a number and it gives us either a bigger or smaller measure, that's how the scale factor works. So please make sure this gets in your notebook under your vocab. Now let's look at our example. It's the same one from before. That scale factor was 50%. Well, we can take 4 times 0.5 times the scale factor, and it gives us 2. Or we could do it as a fraction, 1/2, and 4 times 1/2 will also give us 2. So there's lots of different ways to get the answer, but now we can formally tell that it is called a scale factor. So let's look at number 1. What scale factor do you use to produce circle A's radius given circle B? So we're starting with circle B, going to circle A. Does that mean that we're getting bigger or smaller? Well, we're starting with 2, going to 4, so that means we're getting bigger. So we had the original radius of A, which was 4. And then we had the original radius of B, which was 2. Well, what does this simplify to? It's not 1/2. 4 divided by 2 gives us 2. Well, is 2 bigger or smaller than 1? It's bigger. So it makes sense that our circle should be getting bigger. Well, if we were to write this as a percent, well, this is like 2.00, so we would take that decimal, move it 2 to the right, and that would give us 200%. Well, is it bigger or smaller than 100%? It's bigger. So it makes sense again that we are getting bigger on our circle. So you always want to think about with your scale factor, what's happening? Is it getting bigger? Is it getting smaller? Is your number bigger than 1 or is it less than 1? or less than 100%, or bigger than 100%. You always want to check, and that can help you figure it out. All right, we're gonna have another vocab word, and this is a scale drawing. And so this is how scale factors are used in the real world. So a scale drawing is a representation of a real object or place that is in proportion to the real object or place that it represents. So we use these all the time in the real world. For instance, we can look at the scale drawing of the clock of Big Ben. So obviously, Big Ben, which is a giant clock tower, is way larger than this in the real world, but we can draw it in proportion on a piece of paper. So artists use scale factors all the time. When you go out and explore and you don't know where you're going, maps, you use maps. That is a perfect example of scales and scale factors in drawings. Whenever you go and you're playing like a claw machine and you're trying to win one of the little action figures or like the models, those are also scales of the real object itself. So when we are looking at a scale drawing, the first number represents the drawing length, and the second number represents the real object in the real world. So if we look at number 3, this first one, a scale on a drawing is 1 centimeter to 4 centimeters. Well, think about the 1 centimeter, the number that comes first represents the drawing, and the second number of the ratio represents the real world object. So if we were to write a sentence, we would say for every 1 centimeter in the drawing, it is 4 centimeters in the real world. So if we're thinking about that, is the real world object bigger or smaller than the drawing? It's bigger. Well, now let's look at number 2. A scale on a drawing is 2 inches to 1 inch. I want you to pause the video and write a sentence similar to letter A with the new scale. Let's check to see how you did. For every 2 inches on the drawing, it is 1 inch in the real world. So if we're thinking about it, the real world object is smaller than how it was drawn on paper. So if you're thinking about like drawing bugs or something like that, like an ant, we would probably draw the ant bigger on a piece of paper when in the real world it's really tiny. And then for C, go ahead and pause and write a sentence to represent the scale. Let's check. So for every 1 centimeter on the drawing, it is 1 centimeter in the real world. So that means exactly as we see it in the real world is how we would draw it on paper. All right, so we're gonna do one more example on page 43. We're gonna take a look at this circle. So the circle shown has a scale of 2 centimeters to 3 miles. Now we talked about at the beginning when we were doing our area and perimeter of shapes that this is super important for farmers. So it makes sense that we can have a small drawing, but in the real world it can represent a really large area because those farming areas are really, really big. They're often seen in the West Plains of Texas. Okay, so we've talked about parts of the circle. Let's first find the center. And then let's go ahead and identify the diameter. So remember the diameter goes through the center and starts and stops on the circle. And then we're gonna count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 units. Now thinking about our scale, is it centimeters or is it miles? Well, we are talking about centimeters since it's the drawing and it's the first number. So what we need to do is we need to figure out how much is this in the real world. So I'm going to use this off to the side over here. We're going to take this ratio and we're going to write it as a fraction instead. So I'm going to write 2 centimeters over 3 miles. We're going to set up a proportion. So we're going to do equals and we're going to set it equal to another fraction. Now, what is super important about proportions is that they stay lined up with whatever units we're talking about. Because if we don't, then we would have some drawing that would not be a representation of what it truly is in the real world. So So if centimeters are in the numerator, I have to put centimeters in the numerator on this side. If miles is in the denominator, I have to put miles in the denominator on this side. So we're given 10 centimeters, so we have to line it up where the other ones were, so it's gonna go into our numerator. And then we're going to solve for, we'll just call it D for diameter, so we can figure out what it is in the real world. We have two options that we can do to solve for it. If we have some nice numbers, we can do it this first way. So we can think about 2 times what number gives us 10? Well, we can do 2 times 5. So then what do we have to multiply 3 by to get the diameter? The same number, so times 5. So that means the diameter would be 15. Now think about, is this talking about centimeters or miles? Diameter was in the denominator, so it lines up with miles. So that's what it would be in the real world. Now let's say we don't have some nice pretty numbers. We have a second option. So I'm going to rewrite the original proportion. So 2 centimeters over 3 miles equals, and then 10 centimeters over the diameter. Well, what we can do as a second option is we can cross multiply. So we're going to multiply across, so we have 2 times D, which gives us 2D, and then equals, now we multiply the other way. So 3 times 10, which gives us 30. What's nice about cross multiplication is we had 2 fractions on our equal sign, and then when we do that step, we have no more fractions. Now we just have to solve for D. So we currently have multiplication happening, so we have to use our inverse operation of multiplication, which is division. And we're trying to get D by itself, so that means we have to divide both sides by 2. So then D equals, well, 30 divided by 2 gives us 15. The diameter was in the denominator, so we're talking about miles. All right, so you have the 2 choices. If you have the nice numbers, you can do it at option 1. But maybe we have something that it doesn't go in evenly, or we have some decimals, then do option 2 with your cross multiplication. So now we know that this is 15 miles in the real world. Well, what if we change the scale? So we're gonna do the same thing, just going backwards. So now we have a new ratio of 4 centimeters to 5 miles, but we're still talking about the same original shape in the real world that had a circle that the diameter was 15 miles. So we're gonna set up our proportion, 4 centimeters over 5 miles equals, and we have our second fraction. Well, now we know it's 15 miles. So does miles go in the numerator or denominator? It goes in the denominator. So I have 15 miles. And then I'm going to put D in the numerator because that's what we're going to try and solve for on the new drawing. Let's practice that cross multiplication again. So we're going to do 5 times D. So that would give us 5D equals, now we go the opposite direction, 4 times 15. So that gives us 60. And then our last step is we want to isolate D. So the inverse operation of multiplication is division. So we divide both sides by 5. So then 60 divided by 5 gives us 12. So the diameter equals 12. Now is this in the numerator or the denominator? It's in the numerator, so that means we are going to label it with centimeters. So now let's draw our new circle. So I'm going to choose a point. I know the diameter is 12, so I'm going to count up and from here 6 and then down 6 so I can get the diameter across as 12. I'm going to do the same thing going left and right. Now that I have the 4 points, I'm just going to do my best to connect and make a circle. It's okay if it's not super duper pretty since we don't have the compasses out. All right, So the key takeaway when you are setting up these proportions, make sure you line them up and you're reading your questions really carefully about which object you're talking about, the scale drawing, or the real world object. You have to pay attention so that you can get them set up correctly where they line up. And then you have your choice. If they're nice numbers, you might be able to just figure out what it multiplies by to solve for the other one. But if they're not, then you can cross multiply and solve to get whatever dimensions you need.